All right, so today, what are we talking about? F of g of x. That's where you have a function in a function. It's sort of like Inception. The dream inside the dream. So a function inside of a function. Well, if you know what g of x is, it's not that hard to do this. You just start with the g of x. And if I said g of x was like x, 2x plus 1 or something, I just put that in there. And then I got to do this. This is the harder part. The harder part is when I do f of 2x plus 1. Well, what if the f function is square root of x plus 3? Well, then where can you put this thing? Where do you put it? You put it in where the x was. Okay, so then I'd write square root of empty spot plus 3. I really like that empty spot idea where you put a parentheses around it. And then you can drop it in there and you'd say 2x plus 1. Now, here's an important thing. You do need to simplify these when you can. Like this one I have on the board, could it be simplified? Yeah, because the plus 1 and the plus 3 can go together. And you'd have square root of 2x plus 4. All right. Now, what I tried to teach you yesterday was how do you do those domains again? So a simple kind, let's say I have f of x is 1 over x. And g of x is like 1 over, let's do square root. Square root of x minus 5. Then I got to know my domains of my parents. Would you please write this one down? Write df, that means with a small f, which means domain of f. And write dg. Let me make sure you at least know how to do the domains of those two. By now, those should be coming really automatic for you. And then see if you can answer what's fg. And then this question, what's dfg? Which is asking what's the domain of fg. One little thing at a time. If you can't answer all those questions, just answer what you can. Like I know this first one. Domain of f is all real numbers except x cannot be 0. How about the other one? Another one? Greater than or equal to 5. Good. And you could have got that in case you didn't know that. You could have said x minus 5 is greater than or equal to 0. And x is greater than or equal to 5. There we go. Just solve that little equation. All right. Now, what's fg? We just multiply f, which is this, over x, times g, which is root x minus 5. And then you really should put them together. It's a multiply problem, and I can multiply them. So this has a 1 on the bottom, and it's x minus 5 over x. There. There's my fg. Raise your hand if you had that one. Right. Okay, good. And then the last part, domain of fg. Well, how do you get these? These are the simple kind of domains. You just have to have two parent number lines overlapped. There's a number line. There's a number line. I'd like you to start labeling them. Get in the habit of saying this is domain of f, and this is domain of g. And I'm going to overlap them. Okay, domain of f is everything except 0. After spot. And domain of g is bigger than 5. Here's 5. Bigger than or equal to 5. Can you see where they overlap? They overlap. And they're over. So, final answer for g of fg is all reals where x is greater than or equal to 5. Yes, you could say 5 to infinity like this. But make sure you have a bracket. Okay? Any questions on that? That's the easy level. That's like the basic thing. I know that's a lot of stuff, but that is the basic thing. So now let's take the same idea and do the new step-up variety. Let's see. The step-up variety is what is f of g of x. See if we can get that one. Function in a function. I'm going to have to watch Inception again and see if I can get that straight. So what's g of x? Here, I'm going to just rewrite the problem and show you what I'd do. I'd go, okay, well, I know g of x. G of x is that thing right there, square root of x minus 5. I'd go like that first. And the next step is I got to put that into the f function. This has to be f. And now I'm going to go 1 over that, and I'm going to put this in x minus 5. And that's it. What not? I was talking about functions. So now I've got to figure out its domain. That's the hard part. Sambo, what's up? All right, so there's my function, and now I got to figure out its domain. The domain is based on two things. Do you remember me saying yesterday that you got to start with this domain? Because if that were to fail, the whole thing fails. Is the minute you start with g of x. So there's two number lines again, but it's not these two number lines. It's going to be different. It's this number line's one of them. So g of x, I did have that domain up there before. The domain of g was this one, the 5 to infinity one. So dg is one of them I got to check. The other is the domain of this new function right here. So how do I find its domain? I look at the denominator, and the denominator can't be 0 is one thing, and the square roots can't be negative is another thing. And so I ask myself, all right, well, it could, if I had a 5 in there, it would be a problem. So 5 is the key point, and it would be an empty spot. And then would things like 6 be okay? Yes, it would. So it looks like this. So it's pretty close to the other one. So now when these two overlap, it's the domain of g, and I should really label this the domain of the new function. And some people are calling that the domain of the composite function. I maybe should do that. It's actually shorter than new. I'm going to do that. This is a composite function. So this is the domain of the composite. And then, where do they overlap? They overlap from here over. So it's from 5 to infinity, except this time, the parentheses can't be 5. Why can't it be 5? Because if you put a 5 in there, it crashes. 0 on the bottom. All right. Let's do some of the actual worksheet now. I have a new worksheet for you. I'm going to hand them out. We'll do some together. Yes, we're going to grade the old homework, but not yet. Here's the new one. 1, 2, 3, 4, 5. Number 1's too easy. Let's go on to number 2. I'm just saying you don't need my help with number 1. Number 2. You don't obviously have to write it down because it's on your worksheet. That's one of the benefits of a worksheet. I'm going to write it for a second here. G of x is 1 over x minus 1. Okay. So now, what does it actually want me to do? It wants me to find f of g of x and its domain, and g of f of x and its domain. All right, so I'm going to do f of g of x first, because that's what they list first. So I'm going to stick the g function in there, and I'm going to say, okay, so first thing is f of g is 1 over x minus 1. And then I am going to put that into the f function. Let's see if I differently this time. And then I'll put that in there, empty spot squared minus 1, and then drop in 1 over x minus 1. Now, here's where a lot of kids are going to think that's okay to just leave it right like that, and you'll get it wrong, because you have to simplify whatever you can. And you can square that stuff. What does squaring mean? It means to multiply times itself, and then subtract them. 1 over x minus 1 times 1 over x minus 1. Now, any of you sensing that you don't have near enough space in this worksheet? You're right. So if I were you, I'd get out a separate sheet of paper and go off to the side, because otherwise you're going to be scrunching stuff and you're not going to have room. It's so much easier if you have room. It would be like if you gave one set of kids the permission to do their problem on a great big space with lots of room to write it, and you told the other kid they had to squish it all in. It would be a significant disadvantage to the kid who had to squish it all in because they didn't have room. So don't put yourself at a disadvantage. It's not that hard to grab a piece of paper. Not saying you have to, but it's hard to squish all this in. Then 1 times 1 is 1 over x minus 1 times x minus 1. You got to FOIL this puppy. This times this. X squared minus 2x plus 1. And then I got to subtract 1. And from there, I'm going to give you mercy. Technically, we could get this a common denominator, and then it'd get really, really, really long and painful. But at least I would want you to square that part out. Okay, so there, we're done. Now, what is its domain? It's the domain of the inside one. So to make my 2 number lines, I'm going to make a number line here for G, of domain of G. The domain of the G function is that the bottom here can't be 0, so x can't be 1. So here's 1, and it can't be 1. Could be anything else. That's D of G. Now the other one I have to overlap it with, when you're doing a composite like this, where it's like a function in a function, then you need to do the domain of the composite. So I got to look at this thing. And I ask myself, what would crash that thing? If x was what? If x was 1. So then, same deal. It's the same exact thing. They're not always going to work out that way, but in this case, they are exactly the same domain. So therefore, the domain of the G and the D of the C, and when you overlap them, what do I get? Well, you could just say all real numbers except x cannot be 1. Or you could have said negative infinity up until 1, and it can't be 1, union with 1 to infinity. Whichever way you like better. But see all that? That's supposed to be half of problem 2. Because that's just f of g of x. That's why I'm saying you don't have enough room on your worksheet. Because now we have to do g of f of x. So I first looked at this worksheet and I thought, man, this thing's really easy and short. And then I realized, well, it's not really, because of all of that. So now we're going to go do g of f of x. I don't want to erase all of this, but I think I'm going to just leave that up there and for another minute or two until kids have a chance to get done with that. And one more I want to call your attention to is number 6. Number 6 has this in it. This is problem 6 now. In problem 6, it has a cube root of... Do you remember what I told you about cube roots and how you crash them? You can't. You can't crash cube roots, and therefore, what's the domain of that? All reals. Good. So don't forget that when you get to number 6. All right. Got a lot of time to work, and that's all I have for the video.